So let us try to solve this question. So here it is saying that the crank and connecting rod of a steam engine are 0.3 meter and 1.5 meter in length, right? So crank radius is given. So given data, crank radius r is given to us as 0.3 meter, and the connecting rod length, that is L, it is given to us as 1.5 meter. The crank rotates at 180 rpm clockwise, right? So it is given the rpm, that is n. This is 180 rpm and the direction is clockwise. Okay. So determine the velocity and acceleration of the piston when crank is at 40 degree from the inner bend setter position, right? Okay. So theta is given to us as 40 degree. Okay, so we will be trying to draw the diagram. Then so we can draw the diagram somewhat like this. Okay, so let this be the piston, right? Sorry, that is the cylinder, and we'll be having a piston over here. So let us see, right? This is the piston. Okay. Okay, so this diagram we can construct over here, where this length is given to us L and this is the R. So these two data are given to us, and this is the crank angle, that is theta. Okay, and okay, so when it is actually the position it is given when the crank is 40 degree from the inner dead center, that simply means when the piston would be here, in that case the crank angle would be if we'll be counting from this side, then this would be 0, and it has moved forward. That simply means ये थोड़ा आगे चला गया है, and कितना आगे आगे गया है, that is your 40 degree. So this theta is given to us as 40 degree. Okay. Okay, so from all these data, we have to find out the velocity and acceleration of the piston. Okay. And again, what else we have to find out? We have to find out the position of the crank for zero acceleration of the piston. Okay. So if acceleration would be 0, in that case, what would be the position of the crank? That simply means in that case, what is the angle turned by the crank, that we have to find out. Okay. So let us first try to solve the first part of this particular question, where we'll be finding the velocity of the piston and acceleration of the piston. So for finding the velocity of the piston, so I'm writing the formula. So that is equal to r omega times sine theta plus sine 2 theta divided by n. Okay, so this formula we can use for finding the value of piston over here. So from all the given data, we are given with the values of r and l. So from here I can find out the values of n, that will be equal to l by r. Okay, so l by r, where 1.5 divided by 0.3. So after calculation we'll be getting this value as 5, right? So n we got 5. Then what else will be requiring? This omega. So omega we can find it out. So this will be 2 pi n divided by 60. So all the data are given to us. So 2 pi times n, where it is given to us as 180 divided by 60. So if we be doing the calculation, we'll be getting this as 18.85 radian per second. Okay, so we got the values of omega. Now we can put it in the above equation, and if we be doing so, then we can easily calculate the value of velocity. So let us do that. So if we be putting these values, then v is equal to r omega. So r is given to us as this is 0.3 meter, right? Okay, so 0.3 omega we got as 18.85. okay, and sine theta. So theta is given to us as 40 degree plus sine 2 theta, so that I can write this is 40 divided by 2n. So n, we found out the value, that is your 5. So if we'll be doing this particular calculation, we can find out the value of velocity, that will be equal to 4.19 meter per second. So check it, you can check this value. Okay, so after calculating the value of velocity, we can calculate the value of acceleration, and the formula for finding the value of acceleration, that will be, let me write it down. Okay, so for finding the value of acceleration, we can use this particular formula, where a will be equal to r omega square cos theta plus cos 2 theta divided by n, right? So all these values are known to us. So r is equal to 0.3 and omega, that is 18.85 square, cos 40 degree plus cos, you can write 40 into 2 divided by n, that is 5, right? So if we will be calculating this value, from here I can find out the value of acceleration, that is as 85.35 meter per second square, right? So with this, first half of the question is completed. Now next thing we have to find out, so let us go to the question again. Okay. So in the next half, it is asking for finding the position of the crank for zero acceleration of the piston, right? So if the acceleration of the piston will be zero, in that case, what will be the crank position, crank angle, right? So to find out that, so we have the expression of the crank, we have the expression of the acceleration of the piston, and we have to equate that particular expression with zero, right? So from that we can find out the values of theta. Okay, so let us do that. So this is the expression of, so let us use some other color. Okay, so I can write down, this is the acceleration of the piston, and this is the expression, that is r omega square and cos. So in place of theta, let us write some other angle, that is theta 1 plus cos, sorry, cos 2 theta divided 2 theta 1 divided by n. Okay, and we'll be equating this to 0. Okay, so if we'll be doing some uh, arrangement, then I can write this is r omega square n times cos theta 1 plus cos 2 theta 1 divided by n, that will be equal to 0. Okay, and here uh, we can take all other terms to all the constant terms to the right hand side. Okay, in that case I can find out the n cos theta 1 plus cos 2 theta 1, that will be equal to 0. Okay, then we can do some of the arrangements again. I can write n cos theta 1 plus, so I can replace this cos 2 theta 1 by the 1 minus cos square 2 theta, if 2 cos square theta minus 1. So here this cos 2 theta 1 will be replaced by 2 cos square theta 1 minus 1, and this will be equal to 0. So this is the trigonometric relation. Okay, and here I know the value of n, that I can put it, that is 5 cos theta 1 plus 2 cos square theta 1 minus 1. Okay, so this is a quadratic equation we got, and after solving this particular quadratic equation, we'll be able to find out the value of cos theta 1. Okay, so in this case, so it will be rearranging this particular equation. I can write it down like this: 2 cos square theta 1 plus 5 cos theta 1 minus 1, that will be equal to 0. Okay, so when we'll be solving this particular equation, then I can write cos theta 1, that will be equal to, okay, so it is somewhat related to ax square plus bx plus c equal to 0. So this is a quadratic equation, it is in this particular form. If we will be solving this, then I can write minus b, where b is 5 over here, minus 5 plus or minus b square minus 4ac, that is b, that is again 5 square minus 4 times a, that is 2, and c, that is minus 1. Okay, under root of this, and 2 times a, that is 2. Okay, so if we will be solving this particular uh, this mathematics, this equation, then we can find out the values of cos theta 1. Basically we will be getting two values of cos theta 1, and from here we can find out two values of your theta 1. Okay, so we can find out the values of okay, cos theta 1. So two values of cos theta 1, one when we'll be including the positive sign, other when we'll be including the negative sign. Okay, so here we'll be getting two values of theta 1. So directly I'm writing, so theta 1 will be getting as 79.27 degree, or will be getting this is as 280.73 degree. Okay, so at both these degrees we will be having the zero acceleration of the piston. Okay, so I hope it is clear. Okay, so try to solve many more questions related to this. Okay, thank you.